Thank you, Jerry. And once again, thank you, New Era Software, for sponsoring the zExchange and this opportunity to present the crypto topics. Um, this month, as promised, we're going to cover the latest announcements from IBM regarding the Z13 and crypto. We're also going to touch a little bit on the ZOS 2.2 preview announcement because there are some things in there as well that pertain to crypto and the ability to leverage some of the technology. So with that, let's go to slide 2. As I'm sure everyone is aware of now, by now, I left IBM just over a year ago. It'll be a year early next month. And therefore, I don't have all of the contacts or all of the inside information that I used to have. So this presentation is based on digging through a number of resources, announcement letters, some of the red books, some of the tech docs that are available, and I've got pointers to all of those at the end of the session. But what I've done is I've gone through those and pulled information out about the crypto. And one of the neat things now that I'm not with IBM is, I can point out some of the inconsistencies and maybe some of the confusion or confusing statements in some of the documentation. So I may or may not have things exactly right, but based on 30 plus years with IBM, I kind of understand how they work and some of the thinking that goes on. So with that, let's go to slide 3. And the agenda for today is we'll start out by talking about the hardware, the new hardware that's going to be available, the Z13 and the new crypto card. Then we'll talk about the new version of ICSF that's going to be available to exploit the card. There's some new capability in terms of not just exploiting the card, but new capabilities within ICSF that aren't particularly tied to the hardware. So we'll talk about some of those. There is a new TKE, a new Trusted Key Entry Workstation, so I've got a slide or two about that. And then, as I mentioned before, some of the ZOS 2.2 crypto enhancements that are mentioned in the ZOS 2.2 preview announcement. So let's go to slide 4. So the big part of the announcement, of course, was this new machine, the Z13, and the big news there, which has sort of been leaking out for a while, is the simultaneous multi-threading capability. So this hardware will be able to multi-thread. Now that is, it appears specific to the Unix world or Linux world. ZOS, I don't believe, is going to exploit it at this point, but because that Linux environment has access to the CPAC-F hardware, presumably the CPAC-F will also be able to benefit from that simultaneous multi-threading. The CPAC-F, the hardware that comes with the Z13, that's no extra charge. When you order a Z13, the CPAC-F is part of the hardware. Again, think of it as additional real estate, additional instructions that are available in the machine. And there are some new instructions, or there is a new instruction provided. And the crypto support is referred to as MSA, or Message Security Assist, for providing security for your messages. And there is a new instruction that's available on the CPAC-F hardware, starting with the Z5, the PPNO, or Perform Pseudo Random Number Operation. What's going on here is that the U.S. government, NIST, the National Institutes of Standards and Technology, have updated their requirements for pseudo random number and what exactly that entails. And presumably this CPAC-F hardware will support those new standards as defined by NIST. So you will have the ability to generate pseudo random numbers on the CPAC-F hardware. And if you don't remember, random numbers are important to cryptography because random numbers make good key material. Now, over and above the new instruction, the announcement letter, the Z13 announcement letter, is claiming some pretty significant performance enhancements in terms of encryption, triple DES and AES encryption that's done on the CPAC-F hardware, and it's approximately 2 times faster than the previous generation, the zEC12. The SHA hashing is also improved, and there's even a bigger benefit there. They're claiming 3.5 times faster than the EC12. Now, there are some performance white papers that have been published in the past, and presumably they will be published for the Z13 as well, but they are not currently available, so we can't really look at the raw numbers yet. We'll have to wait for that document to come available, and typically that comes out sometime a couple months after the machine goes GA. Let's go to slide 5. And there is a new Crypto Express card that's going to be available with the Z13. The next generation logically would be named the Crypto Express 5S, following on the 4S. Now, everybody that's familiar with IBM knows that they are very careful and very cautious about not pre-announcing things. But it appears they may have slipped a little bit in this announcement letter, because in the announcement letter, there's a new feature associated with the TKE, the Trusted Key Entry Workstation, and it talks about a 4767 adapter that's available for the TKE. And we'll talk more about that in a little bit. But that 4767 nomenclature kind of indicates that there is a new coprocessor chip that's available. The Crypto Express 4S and the Crypto Express 3 before it relied on the 4765 coprocessor, and the crypto cards before that relied on the 4764 coprocessor. So it appears that the Crypto Express does in fact have a new chip on it, this 4767 chip. You probably don't really care about it. What basically it's just going to be the next generation in crypto engine, and it's going to have all of the capabilities that the previous generations had, plus some more new capabilities. But the fact is, it does look like there's a new chip. The other big piece of the announcement was support for more domains and the ability to support more crypto domains on the card. If you remember, the Crypto Express 4S and basically all of the cards before that, they could be shared by up to 16 different LPARs. That is, there were storage on the card for up to 16 different master keys, each of which could be associated with a different LPAR. Now, depending on what document you look at, some of the documents talk about more than 16 domains. There's also a couple places where they talk about more than 85 domains. And there's a place or two where they talk about being able to support 256 domains. Probably at this point, the safest thing to say is it's going to be able to support more than 16 domains, and it looks like at least up to 85, with the potential to later support up to or maybe even more than 256 domains. But that has implications, especially if you're running in a VM environment with multiple Linux guests. Today, you can only support 16 Linux guests on a card. With this new more than 16 domain support, conceivably you can support 85 or 256 or significantly more guests running in that environment and having access to the Crypto Express card. There's the current technology, the Crypto Express 4S and all the way back. You could have up to 16 cryptographic engines installed. So with the Crypto Express 4S, there was one engine per feature. You could install up to 16 features and get 16 engines. It looks like that restriction is still in place. However, there are some hints in the announcement letter and in some of the documentation that eventually they'll be able to support even more Crypto Express engines. So once again, if you have an environment with hundreds or maybe thousands of Linux guests, This support might be important to you in that you can give all of those guests access to cryptographic engines once there are more engines available on the card. Just like with the CPAC-F, the announcement letter is claiming improved performance for all three configurations of the card, whether it's configured as a CCA coprocessor, as an accelerator, or in PKCS 11 mode. But once again, we'll have to wait for that performance white paper to come out to see exactly how much of an improvement there is. As with previous generations, the Crypto Express card is an HSM, a hardware security module. Previous cards have been certified as FIPS 140-2 Level 4 compliant. The Crypto Express 5S will, according to the FAQ, the Crypto Express 5S has already been submitted for certification for FIPS 140-2 Level 4. So it's in process. That normally takes a while to get completed. So I expect at some point in the future, IBM will announce that it has achieved compliance. And if for some reason it doesn't achieve compliance, I'm sure that's something that IBM would try and fix quickly and get that level of certification. Now, in addition, some of the documentation does talk about conforming to some other standards, the ANSI X9.97, and then the DK standards are a German banking set of standards. So there are a number of customers that are subject to those European German banking requirements, and they've requested similar levels of certification. It's not clear that IBM is going to go through that certification process, but certainly the card is designed to meet that. And then similarly with PCI, the payment card industry standards, the DSS standards that everybody's heard about, they have also issued some hardware compliance certifications. I know when I was with IBM, they were looking at what it would take to get through that certification process. Once again, it's not clear from the announcement letter and some of the documentation that they are going to pursue that, but they have certainly looked at the PCI HSM requirements and tried to get as close to them as possible and tried to set things up so that they could possibly be certified as PCI HSM certified. And then the last bullet on there, I just want to mention that IBM did come out with another announcement letter. The Z13 announcement letter was a little bit wishy-washy. There's some indication that they were planning on supporting the Crypto Express 4S on the Z13. However, there was another announcement letter, and again, that one's referenced at the end of the presentation, that they are not going to support the Crypto Express 4S on the Z13. So you won't be able to bring your Crypto Express 4S forward to the Z13. If you need Crypto Express cards, you are going to have to order the new feature code 0890, the Crypto Express 5S for that machine. Let's go to slide 6. So along with announcing this hardware, IBM will have a new version of ICSF available, and that should already be available on the IBM Downloads website. It's so you could go out there today and download that software and install it on your current machine. It will run on your zEC12. It'll run on the older machines, and it would put you in a position to be able to exploit fully the Crypto Express 5S and the new CPAC-F hardware once it's installed. Now, this description here is cut and pasted pretty much from the web download site. The bold highlighting is what I've added, and I think we're going to touch pretty much on all of those capabilities as we go through the rest of the discussion today. So let's go to slide 7. One of the big line items in the Z13 announcement is the support for format preserving encryption. So format preserving encryption is the idea of encrypting data in such a way that the characteristics of the clear text are preserved in the ciphertext. So for example, social security number is a 9-digit number. if you encrypt that social security number using a format preserving encryption algorithm, the ciphertext will also be a 9-digit number. So the beauty of FPE is the idea that you could implement encryption with an application without having to change the application logic. So for example, a credit card number is a 16 to 19 digit numeric value. And the last character in a credit card number is actually a checksum, a check value. So what you could do theoretically is take the first 15 to 18 digits, the actual account number, and you maybe even strip out the bin, and it's only going to be 5 to 8 characters or whatever. The actual account number wouldn't be encrypted using format preserving encryption. The bin number on the front would be preserved, so any checks that are performed to see if it's a valid bin would still be successful. You would calculate a new LUN-check value, that last character, for the ciphertext version of the credit card number, and any checks that are executed to make sure it's a valid security or a valid credit card number would still be preserved. So IBM has announced support for FPE in both clear key and secure key. Um, they have chosen to implement the Visa format preserving encryption algorithm. That's just one of several algorithms that have been proposed as standards. And we'll see in later slides that there are APIs that will execute DES, triple DES, AES encryption in such a way to preserve the format of the clear data. So with that, let's go to slide 8. There are a number of new APIs that are available to implement the format preserving encryption. So these APIs, there's 3 on this slide and there's 2 on the next slide. These 3 are particularly associated with credit cards and PAN data. So you have, excuse me, you have the ability to encipher and decipher data that's on a credit card, whether it be the PAN, the cardholder name, or the track 1, track 2 data. If it can encrypt either in ASCII or binary format. There's also an FPE translate, so you can re-encrypt data from one key to another without having that data be in the clear. So because these APIs are associated with credit card data, they are implemented using secure key triple DES encryption. So this does not support clear key. That data, that PAN or the track data will not come into storage in the clear when you're doing a translate. So it provides some very strong security for the credit card data that's on the card. Let's go to slide 9. There are 2 additional APIs that are available that would be typically used to encrypt data that might be in a database. Now, for example, if you had a credit card number that's stored in a database, you could use the field level encipher and the field level decipher to encrypt using format preserving encryption and encrypt and decrypt that data that's going to be stored in the database. So this is not associated particularly with the card, but it might be PCI or PAN data or any other data for that matter that would be stored in the database. So within a single call to the API, you can encrypt data, whether it be numeric data, ASCII data, character data, EBCDIC data, and preserve the format of that data within the field. Now, these APIs can be implemented either using secure key, clear key, or protected key. So there are some different levels of protection there. Now, once again, PAN data, if you're encrypting a credit card number that's going into the database, you might want to put some stronger security and maybe use protected key, or if you can handle the performance, secure key. But you have the choice of which technology you want to use. Clear key is going to get routed to the CPAC-F hardware. Secure key is going to get routed to the Crypto Express hardware. Protected key is going to take advantage of both. Now, If you go back and look at the principle of operations manual and you look at the instructions that are available, there is not an FPE instruction that's implemented on the CPAC-F. So presumably it's going to use the DES, triple DES engine or the AES engine, and then ICSF is going to do some manipulation to implement the format preserving encryption part of that. So just be aware that there's not a new instruction to do FPE on the CPAC-F hardware, but you do have the capability with the existing triple DES and AES. There's just some additional work ICSF is going to have to do for you when you're performing the FPE for that data. Let's go to slide 10. So changing horses a little bit, another new capability that's available starting with HCR 77 Baker are some tools for managing your key material. Now, if you remember, with HCR 77 Able Zeros, so 2 generations back of ICSF, there was a new format for the key stores called KDSR. KDSR it was KDS reformat of your key stores to provide some additional fields. One of the things that happened is, as part of this, was all of the key stores, the CKDS, the PKDS, and the TKDS, were kind of standardized in terms of the record format and the record layout. So they're all similar. But it gave IBM the ability to introduce some additional fields into the records. And in fact, those records are now variable length. So they can include some metadata with the key material. And one of the big things that people have been asking for is the ability to look at keys, look at when they were created, when they were updated, when they were last used. So there are several new fields in the HCR 77 Baker 0 version of the KDS to keep track of those things and to record the date when it was created, the date when it was updated, the date when the key material was last used. There are also some archive flags so that you could archive a key. Now, the idea here was that customers wanted to be able to retire a key, and that is no longer make it available. But prior to this support, the only way to do that was to delete the key from the key store. So IBM had to find a way that they could get rid of a key without really getting rid of it. They looked at creating another archive key store. And so if you decided that a certain key needed to be archived, it would be taken out of the active key store and moved to this archive key store. The problem with that was if you change your master key, so let's suppose you have a key that's encrypted under the master key, you archive it, move it to the archive. Now you come along and do a key change. Well, how do you handle that archive? Do you go back and reformat the archive and re-encrypt all of the keys in there? They didn't want to go that direction. So basically what they did was just add a flag in the key store that says this key has been archived. And that gives you the capability to restrict the use of a key that's been archived. And we'll talk a little bit more about those restrictions and you can overcome them. But there are some additional flags in there now. There's also some additional fields, some IBM defined and some installation defined metadata blocks. So you can store your own metadata in these records as well. Let's go to slide 11. With these new date fields, one of the things that ICSF can do for you is enforce this concept of validity dates. So you can define a start date and an end date such that if those dates, if you fall outside of those dates, ICSF won't let you use the key material. So for example, here in March, you could create a key today that has a start date of June 1st, 2015, and maybe an end date of May 31st, 2016. If you tried to use that key tomorrow, ICSF won't let you use it because the validity dates have not been reached. That gives you the ability to help with key change operations, and as you need to change operational keys, you can create keys today with some confidence that they won't be used until the validity dates have been reached. Now, ICSF is going to honor those validity dates, but if you export a key and send it to a partner, and if they're using ICSF and they import it in their environment, they may not give it the same dates as you do, or if they're not running ICSF, other applications aren't going to honor those validity dates. But at least within your own ICSF environment, you can enforce validity date checking and not let people use keys until they're supposed to use them, and maintain some of those key change schedules. With the archive flag, as we mentioned, you've got the ability to flag a key as being archived, so it's still in the database but not going to be used. There's also the prohibit archive flag, so you can decide, this is a particularly important key and I don't want it just accidentally getting archived. You can turn on a flag that says don't allow any utility or anybody to come along and archive this so that it's not available at some point. Now, with archiving, if you there's also the option of a xFacility profile in the xFacility class. You can create a profile that says I want to allow archived keys to be used. So if you're just implementing archiving, what you might do is you might go on and turn on this profile to start with, and then for the first month or two, any use of a key that's been archived won't be flagged, and it'll give you a chance to ease into the process and turn it on without breaking things. Again, a Type 82 will be record, or Type 82 record will be generated when you try and use an archive key, or if you recall a key, an archive key, try to turn off the archive flag. There's also an option in the startup options, so you would specify this in your options data set, key arch message yes, which tells ICSF when someone uses an archived key in a job, go ahead and cut a message to the job log so that you have some record, and if somebody's monitoring the job log, they can say, oh, we tried to use an archived key, let's go back and figure out, are they using the right key? Should that key really have been archived? Give you a way to check and make sure that you are using the correct key material. Let's go to slide 12. There are some new APIs to manipulate the metadata that's available. So there's a metadata read and a metadata write. These APIs will work on the CKDS, PKDS, or TKDS, and it gives you the ability to set and change some of those metadata fields, change some of those dates possibly that are in the key store in the record. Presumably, there will be some utilities, whether they come from IBM or other partners, that give the ability to do key management based on those dates. There's also a new API. It's called the ICSF Multipurpose API. It gives you the ability to basically scan the key stores and validate the key material that's in the key stores. So you might want to do that maybe before a master key change, just to check and make sure that everything's kosher, that there won't be any problem when you do a key change. Now, if you have good master key change policies, I can't imagine an environment where you would mess up the record and get it into a position where it wouldn't validate. But, God keeps creating smarter fools. So, it's possible somebody could change something, or, maybe execute this metadata write API and put some bad data in there that would cause the master key change process to fail. Now, it's not real clear from the manuals, but it looks like there is one ICSF panel that you can invoke this multipurpose API to perform the check. And I've got a screen on that later. It doesn't look like there's a utility that you execute. It's only available via the panels, or you could write your own application to invoke this API and perform this validation. Let's go to slide 13. And here's the slide. So This is a similar screen to one that exists today with the current versions of ICSF, but new on this screen are those options 6 and 7. So option 7 will check the keys that are in the key store and presumably execute that multi-purpose API to perform the check. This check will be done for either the CKDS or the PKDS. It doesn't look like it's available for the TKDS, but this is how you would perform that validation maybe before you do a master key change up there with option 3. Also new on the slide is option 6, the coordinated CKDS conversion. Uh, One of the messages talks about a utility to convert from the old KDS format to the new KDS-R format, but there doesn't appear to be any utility that's documented. This option 6 looks like it's the only way to perform a KDS-R conversion. So presumably there will be some panels behind this where you point to your current CKDS, you point to a new CKDS that's defined with the variable length VSAM data set, and it will perform the conversion from the old format to the new. Let's go to slide 14. There are some new health checks that are available. Now, some of these are not really new to 7.7 Baker Zero. They've actually been around a while, but they're just now getting documented with the current manuals. There is the deprecated service warnings that is new with Baker Zero. What they've done is given the ability to catch if you're using an API that has been deprecated. So those 4 APIs are actually associated with that very old PCF technology, the program cryptographic facility. Those APIs are being deprecated. So this health check will catch if you have an application that executes one of those APIs that's no longer going to be available. There's also a key expiration API, so you can go in and search for keys that are going to expire within the next X number of days. By default, that is 60 days. The health check, and this is a health check parameter, not an ICSF parameter. You can override that expiration date and maybe look for keys that are going to expire in the next week or the next 6 months, whatever you would like. The 3 RACF checks down at the bottom, they have been recently introduced to provide some checks to make sure you're protecting your cryptographic environment properly. The sensitive resources will look at things like the CKDS, the PKDS, and TKDS and make sure that those data sets have the proper level of security, that you have a profile defined that's protecting those key stores. As we've talked about before, no one except the ICSF region needs access to the key stores. So you want to have good protection around those. And that RACF sensitive resources health check will just let you know if there's not profiles in place to protect those key stores. The CSF serve active and the CSF keys active will tell you if those classes are active and that you are doing the proper checks to make sure who is authorized to use an API or who is authorized to use a particular key. So it's just checking to make sure those those classes are active. On slide 15, there are a couple new startup messages. We really already talked about the key arch message. And again, that'll give you a record if somebody uses a key that's been archived. It'll just generate a message to the job log so you can go back and check that and make sure you've got things configured properly. There's also a new startup option called RNG cache, and you can set that to yes or no. If you remember back in HCR 7.7 IBM implemented the capability to generate a cache of random numbers. That'll give you better performance. So prior to this support, if you needed a random number, then presumably you were going out to the Crypto Express card and you had to wait for that to come back, that to complete to get your random number. With the cache support that was introduced, when ICSF starts, it will build a cache of random numbers. And then when you execute an API to get one, instead of going out to the card, it'll just pull the next one out of the cache. Now, for whatever reason, I guess some customers decided they didn't want to take up storage and memory maintaining a cache. You now in 7.7 Baker 0 have the option of disabling that cache and letting it go back to the way it worked prior to the cache support. Both of those options, excuse me, are reflected on the ICSF installation options panel. So you can go look and see how the environment was configured from the options panel. So let's go to slide 16. Another new capability in 7.7 Baker 0, or a pretty significant change, I think, in 7.7 Baker 0 is IBM is changing the way it identifies crypto cards. Way back when we had the PCI-CC card, it was identified with a Charlie. PCI-CC Charlie, the PCI-XCC was configured or was identified as an X, and an accelerator was defined with an A. Now, when the Crypto Express 2 came out, the Crypto Express 2 could be configured as either a coprocessor or an accelerator, and they identified those as E or F. With the Crypto Express 4S, with that, they went to the two-character nomenclature, so it was an S Charlie for a coprocessor, SP for a PKCS11 card, and SA for the accelerator. With Baker 0, they're changing that nomenclature to make it a two-character, so things will be kind of straightforward in terms of when you look at the designation, and we'll see it on the next slide, I think, when you'll immediately be able to tell. You don't have to remember, oh, an easy is for a Crypto Express 2 that was configured as a coprocessor. Now that would show up as 2 Charlie. Crypto Express 2 configured as a coprocessor. So let's go to slide 17. So again, this is the chart where you would see that. Over on the left, you see the cryptographic feature. That first one is a 5 Charlie, so that's a Crypto Express 5 configured as a coprocessor. The last one, 5 Able, is a Crypto Express 5 configured as an accelerator. The numerics there are the engine number, so that would be 0 through 16, whichever adjunct processor is installed. So the SMF records, lots of places where this will show up, but IBM has implemented that new convention for identifying the crypto cards that you might have installed. Let's go to slide 18. Talked a little bit about the record type 82 before. There are some new subtypes available with the type 82. The subtype 30 gives you information about archiving if you've got the key store policy archive turned on. So you can check on whether somebody is using an archive key or not. Subtype 9 has been updated so that if you make a change to metadata in the key store, those changes will also be logged in a type 82 record as well. And back to the subtype 30, I don't think I made that clear. If you use a key that's been archived, this record is going to get cut. It's going to tell you which key store, CKDS, PKDS, TKDS, which key label, and whether you're trying to read it or change the record in the key store. Let's go to slide 19. There is now support for this dynamic exit capability. And this is really a generic ZOS capability, but now ICSF is going to support it as well. And from the documentation, it appears that the goal here is to give you the ability to generate some statistics. The exit will be called whenever an API completes. And theoretically, what you could do in this exit is, count the number of times the API was executed. So you could start generating some statistics and know just how many times a secure key encryption is being performed or a clear key encryption is being performed via the APIs. So that looks like that could be very interesting capability, and IBM is moving to provide some more performance data and some more metrics about what's going on in your crypto environment. On slide 20, didn't really see this called out anywhere, but it happened to catch the fact that if you are running CICS, when you upgrade to 77 Baker Zero, you are going to need to change your RPL DD statement to add the ICSF shared libraries. That has not been a requirement before, but it looks like it is a new requirement with 77 Baker Zero. On slide 20. Couple other things we'll go through real quickly. There's some new options in terms of AES encryption and using counter mode, and that's going to be retrofitted back to all the way back to 7780. There are some enhancements for translating public-private key material, so you can translate between formats. That's going to be retrofitted back to 7790. There's a new field in the CCVT. The CCVT is kind of the anchor block for ICSF, and now there's a field in there that you can query to see what version of ICSF you're running. It should make it a little bit easier to figure out what version of ICSF if you need that from an application. There's also a new communication level. It's really only documented in the messages manual, at least as far as I could find. And if you go back to ACR 7790, when IBM implemented the coordinated master key administration, all of the members of the Plex have to be running at level 2 to be able to do coordinated KDS administration. Well, now with 77 Baker Zero, it looks like there's a level 3 communication that's supported, and all of the members of the ICSF Plex have to be running at level 3 if you want to convert from a KDS to KDSR format. So if you're running just, if you're not sharing your key store, this is not a big issue. As long as you're running 77 Baker Zero, you can run that utility or run that, go through those panels to do the conversion. If you're sharing, all of the members of the Plex are going to have to be at COM level 3 before you can do the change the format. There's also a new message being issued. It looks like this message is going to get issued every time ICSF comes up, and he's going to tell you a little bit about the key stores in terms of their average size. Now, presumably, at some point, IBM is going to issue some guidance that says, if you see these kind of numbers, you may want to look at changing your VSAM definition, maybe making it a little bit bigger or smaller as appropriate. But right now, there's not any guidance. It's just this is kind of an informational message so that if IBM needs to help you do some tuning or maybe do some debugging, they can look at this record and see what the average size is. Let's go to slide 22. There is some toleration maintenance that you need to be aware of if you're going to install the Z13 and the Crypto Express 5S's. That is, if you're not upgrading ICSF, so you're going to take your existing system with an older version of ICSF and migrate it to the new hardware, those older versions of ICSF don't know what a Crypto Express 5S is. So OA45547 provides toleration. When those old versions of ICSF see this new animal, they'll say, oh, okay, we don't know what that is, but we'll just treat it like a Crypto Express 4S or possibly a Crypto Express 3, which takes us to the second APAR, OA39075. Those older versions of ICSF, the 7780 and 7790, they don't know what a Crypto Express 4S is either. So there was toleration maintenance that said, okay, when we present a Crypto Express 4S to you, just pretend like it's a Crypto Express 3. Of course, you'll be limited to the whatever the capabilities of that older version of ICSF is, but at least it will be able to use the Crypto Express 5S and use the functionality that was available on the older cards. So let's go to slide 23. Some coexistence APARs, and this is really business as usual. Every time a new version of ICSF comes out, if you're sharing your key store between plexes, between ICSF levels, those older levels may not know what some of the new records that have been introduced are. So for example, down at the bottom, 7790 introduced the variable length CKDS key support. If you want to share with an older version of ICSF, that older version of ICSF needs to know about that new format. And if you're jumping from 7780 or 7790 to 77 Baker 0 and sharing with the system that's still running 7780, that APAR's got to go on that old system because Baker 0 introduces this variable length CKDS support, and you don't want that old system choking on it. With the top one there, that's a new key store record format that was introduced with 77ABLE0. So if you're sharing a Baker 0 system with the 77ABLE0 system, that 77ABLE1, you need that APAR on so he won't choke on that new format. On slide 4, I want to quickly talk about the TKE and the new capabilities there. As I mentioned before, there is a new workstation available. And when we've talked about the TKE before, we pointed out the TKE basically just runs on the same hardware platform as an HMC. So an HMC is an Intel workstation running an embedded operating system. The TKE is running on an Intel workstation with an embedded operating system. It has one application installed, the TKE application, which is that TKE 8.0 LIC, the licensed internal code that's installed on top of it. Once again, with the Z13, there is new TKE hardware available. So your new workstation, a new Crypto Express card. But you can upgrade your existing TKE 7 system to TKE 8.0. To do that, you would have to install that TKE 8.0 LIC. You don't have to buy the hardware, the workstation, but you got to buy the LIC. And there is a new crypto adapter, this 4767 TKE crypto adapter feature. You would have to install that new adapter in your TKE 7 hardware. And that, once again, that new adapter is based on the 4767 chip. That's what you would need to manage a Crypto Express card on the Z13, the Crypto Express 5S on the Z13. There's a new feature code for smart cards and smart card readers. Presumably IBM is getting those from a new supplier, or they're slightly different from the ones before it. But you can install the smart card readers and use smart cards to store your key material that's being managed by the TKE. Let's go to slide 25. A TKE 8 can manage a can be connected either to a Z13 or an EC12 or BC12. Now that support isn't available until April 14th, according to the announcement letter, but you can connect that TKE 8 hardware and LIC to either of those two platforms. In addition, on slide 26, that TKE hardware can manage coprocessors all the way back to the Crypto Express 2. So you can connect the TKE to an EC12 or a Z13, but it can manage cards that are on other machines in your complex. It can communicate from that Z13 back to a Z196 that has a Crypto Express 3 card installed. So the point is that the TKE 8.0 can manage crypto cards from the Crypto Express 2 all the way forward to the Crypto Express 5S. Let's go to slide 27. With the TKE 8, the new TKE 8 version of the application, obviously you can now support the Crypto Express 5S cards, and that includes migration support. So there's a migration wizard where you can collect information from your Crypto Express 4S and the way it's configured, and then turn around and push that information to your Crypto Express 5S and create the same configuration on this new 5S card as opposed to the 4S. So it greatly eases the process of upgrading your Crypto Express or your crypto configuration. The new TKE can support the greater than 16 domains, whether it's 285 or 256 or whatever, the TKE will support those as well. The TKE will support a new FIPS certified smart card. Actually, there was a FIPS smart card, FIPS certified smart card available before, but this is a new part number, so it may be from a new supplier. Or not sure exactly what the difference is, but there is a new FIPS certified smart card that's available. There's a full function wizard support for the EP11 mode. So if you're running your card in EP11 mode, you can capture information about that card and push that forward to the 5S as well. There's also some new wizards for managing master keys. Those were actually generated in earlier versions, but the wizards have been updated and enhanced a little bit to make the master key entry process a little bit different or a little bit easier going forward. Let's go to slide 28. Um, there's a new smart card reader available indicator. One of the problems that people ran into with the previous versions of the TKE, you couldn't always tell if the smart cards were available and that you could use them. Well, now there's going to be a flag. There's going to be something displayed on the current screen to show you that, in fact, the card is active, or the smart card reader is active and available. There's some new options for generating and displaying hashes that are associated with master keys. As you may remember, you can't go in and look at your master key and see what the master key looks like. But to give you a way to know what the master key is or whether it's changed, what ICSF and what the TKE will do is they will display a hash of the master key value so you can compare master keys between two registers to see if they're the same or not. There's some new options, some new capabilities in terms of which hashes are used or whether you use encrypt zeros. And encrypt zeros just means they'll take that master key and encrypt binary zeros and show you that as the result. And if that value is different for two registers, you know the master key is different between those two registers. There's also new, and this is kind of significant, is the print capability on the TKE. Customers for a long time have been asking for the ability to print key material from the TKE. And I'm not necessarily recommending that you do that, although, you know, for the truly paranoid, you want a hard copy of what your key material is so you can carry it in case of a disaster. If the TKE is not available, you could manually go load that value. So I can understand why customers want it. Historically, the TKE, the operating system hasn't supported print capability, but with TKE 8.0, they are supporting some limited capability to print from the TKE, and I think lots of customers are going to like that. On slide 20, the next couple of slides are going to highlight some of the information in the ZOS 2.2 preview announcement related to products and capabilities that leverage the crypto infrastructure. For example, with System SSL, there's now support with by HTTP to retrieve and manage certificate revocation lists, CRLs. The capabilities have been updated to match some of the new RFCs that are out. There's support for new PKCS 12 certificate files that makes it a little bit easier to interop with other systems. There's now EP11 secure key support. So historically, System SSL has always done clear key at the record level. But now with this new support, you can configure your environment such that the record level could use secure key, albeit in an EP11 mode. So you would have to have your cards configured in PKCS 11 mode to be able to take advantage of that. Let's go to slide 30. PKI services has also had some enhancements. That first bullet, you can now have multiple approvers. Prior to this support, it only took one person to approve a certificate for generation. Well, now if you have some really important certificates that you might want to flag and say, hey, two people have to sign off on creating this certificate because it's going to be so powerful. You can now optionally implement that and require two people or multiple people to approve the generation of a certificate with a particular security environment. OCSP, the Online Certificate Status Protocol, has been updated for RFC 6277. There's some new SHA support for signing certificates. And A-Mode 64 collars are now fully supported as well with PKI services. 31. OpenSSH is now going to be included as part of the base ZOS operating system. And along with that, the version that's going to be implemented is the most current version of the IBM Ported Tools, version 1.3.0. So you will have the ability, you won't have to go install these tools. They'll come as part of the operating system. And you now have the capability to do encryption for remote login and for file transfers under the OpenSSH environment. Let's go to slide 2. ComServer has been updated to meet the NIST SP 800-131A requirements. That 800-131A has that long title of recommendations for transitioning the use of cryptographic algorithms and key links. And what that document describes is some of the limitations on key links and key strengths that you can use. For example, double-linked keys are still considered secure, at least until the end of this year, after which NIST says you should not be using double-linked keys. So there's some new standards, some new dates, new algorithms that need to be supported. So as you're coming off of double-linked keys, you have some additional options in what algorithms you can use. Those are defined in this NIST publication, and ComServer is being updated to support all of those new capabilities as well. On slide 3, will now be in ZOS 2.2 support for signed SMF records. So what you can implement is you can digitally sign those SMF records so you have some integrity in your audit data that's captured. It will use the CPACF hashing algorithms or the hashing algorithms that are available in the CPACF. If you choose to sign those signatures and provide even more integrity, it's going to use the Crypto Express card to generate those signatures as well. Slide 4. As I mentioned before, there haven't been any performance white papers, or the traditional white paper that documents crypto performance on the platform has not been published yet. I've heard that it is going to be published within a couple months, but it's not available yet. I did stumble on that second presentation there, which is focused on Java performance. It looks like there's some pretty significant improvements in Java, especially when it's using crypto. Again, maybe that's because of that simultaneous multi-threading support, but the numbers do look pretty good for Java. I expect the numbers to be very good for the rest of the hardware as well. On slide 30. On the next couple of slides, I want to talk about the other operating systems that are available to run on Z13. And these slides are basically drawn directly from the announcement letter in terms of the support required. So this first slide just talks about the Z13 in general, although it does call out the Crypto Express 5S as well. These are the minimum levels of these operating systems that you're going to need to run with the Crypto Express or the Z13, including the Crypto Express 5S. This will just provide toleration support basically. But notice that ZVM 6.2 and 6.3 both call out the ability to do enhanced crypto domain support on the Crypto Express 4S. But if you remember, there was a later IBM announcement where they formally withdrew support for the Crypto Express 4S on the Z13. So that capability is not going to be there at all. Let's go to slide 36. So this slide is specifically talking about the ability to use the Crypto Express 5S on the Z13 and some toleration PTFs that are required. First of all, let's talk about Linux down there at the bottom. As you may recall, when IBM will not pre-announce, so they don't go to SUSE or Red Hat and start talking about support for new hardware until the product GAs. So now that the product is GA, they've likely gone to SUSE and Red Hat and said, hey, here are the drivers for the new hardware. Can you bundle them into your next release of the product? So they're working with the partners to get that added. Notice here that I don't understand why on the previous slide they had a bullet for both ZVM 6.2 and 6.3, but on this slide they only have version 6.2. So there's a little bit of inconsistency there. And again, the Crypto Express 4S is not going to be supported on the Z13, so that's not an option. Let's go to slide 37. And this last slide is calling out just some more detail in terms of specific support for the Visa format preserving encryption and the support of greater than 16 domains that you're going to need certain PTFs installed as well. Now, once again, it's a little bit of confusing why they don't call out ZVM 6.3 on this slide. So my basic comment is you need to check the buckets as you're moving in this, as you're installing your Z13. Make sure you've got the latest maintenance and all of the maintenance that's called out in the buckets. So let's wrap things up on slide 38. The material that we've covered today has come from all of these different references, starting with the announcement letters at the top. There's several red books that are available. Some of those are still in draft format, but they've been very useful. There are some web pages that talk about the Z13 and FAQs associated with the Z13. And then I also want to mention that I did look at the presentations that Harv Emery and John Eels did at the most recent share in Seattle, and those were all very helpful in pulling this together. So with that, I'm just a little bit over, and I will turn things back over to Jerry to open it up for questions. Thanks, everyone.